Welcome to today's session on exception handling in C++. This is day 22 of our object-oriented programming course, where we will dive into the concept of handling errors, ensuring smoother program execution, and better user experiences. Let's start by understanding what exceptions are. An exception is an event that disrupts the normal flow of a program. They can happen during execution and may be caused by errors like division by zero or invalid input. There are two types of exceptions: logical errors, which are mistakes in your program's logic, and runtime errors, which occur while the program is running, such as accessing invalid memory. Why should we handle exceptions? There are several key reasons. First, handling exceptions helps with error recovery, preventing your program from crashing. It allows the program to continue running after an error occurs. Second, it provides useful feedback to users, helping them understand what went wrong. Third, it keeps your code clean and organized by isolating error-prone code in try-catch blocks. Lastly, it ensures proper resource management like choosing files or releasing memory, like closing files or releasing memory when an error occurs. Next, let's look at the try-catch blocks. These are the fundamental constructs used for exception handling. A try block contains the code that may throw an exception, while the catch block catches the exception and handles it. This separation helps maintain the flow of the program even when something unexpected happens. Here's the syntax of try-catch block. In C++, the try block is followed by one or more catch blocks. The catch block catches exceptions thrown in the try block. In the example, we catch exceptions of type std::: exception and print the error message using the what method. This allows us to gracefully handle errors instead of letting the program crash. Let's look at a practical example. Catching a division by zero error. In the code, if the denominator is 0, we throw a std::: logic error. This error is then caught by the catch block, which prints the error message. This is a simple way to handle one of the most common runtime errors. Now let's talk about custom exceptions. While standard exceptions like std::: exception are useful, sometimes you may want to create exceptions specific to your program's need. A custom exception is a user-defined class that inherits from std::: exception, giving you more control over error handling in particular situations. To create a custom exception, we define a class that inherits from std::: exception and overrides the what method. This method returns a custom error message when an exception is thrown. In this case, our custom exception, invalid exception, returns the message invalid input encountered. Here's an example of how to throw and catch our custom exception. In the try block, we throw an instance of invalid input exception. The catch block then catches this exception and prints the custom error message using the what method of the exception class. Now let's move on to an exercise. In this exercise, we will create a custom exception to handle invalid input in a banking application. The goal is to catch errors like negative deposit amounts or incorrect account numbers before they can cause problems in the system. To start, we define the custom exception class invalid input exception. This class overrides the what method to return a specific error message whenever invalid input is encountered. Let's see how this fits into the banking app. Here's a full example of our banking app. The bank account class contains methods for depositing and withdrawing money. If the user enters an invalid amount like a negative value, the custom exception invalid input exception is thrown. The exception is then caught and the appropriate message is displayed. Now we run the banking app with some test cases. In the first test case, we try to deposit a negative amount which triggers the invalid input exception. In the second test case, we try to withdraw more money than available, which again triggers the exception. The program handles both errors gracefully without crashing. To recap, exception handling helps us manage errors effectively in C++ by using try-catch blocks. We can also create custom exceptions to handle specific errors that arise in our program. These tools help ensure our programs run smoothly, even when unexpected events occur. Here are some best practices for exception handling. First, we use exceptions sparingly, only for true exceptional situations. Second, catch different types of exceptions separately for more specific handling. Lastly, always ensure proper cleanup of resources like files or memory, even if an exception is thrown. For further practice, try implementing other types of exceptions like std::: out of range and add more complex error handling logic to the banking app. You can also expand the app to include file operations or network related exceptions. That concludes the presentation on exception handling in C++. Do you have any questions or would you like to discuss any of the concepts in more detail?